In the previous lesson, we were introduced to scientific notation. That is the idea of using exponents with base 10 to represent very large or very small numbers, which, as the name suggests, is really useful in science, where we have to deal with very large or very small things. Now, just having numbers in scientific notation is not particularly useful if we can't actually do anything with those numbers. So today we will look at how to multiply and divide numbers when they're written in scientific notation. To multiply and divide numbers in scientific notation, the leading digits can be treated as ordinary numbers, and the exponents can be simplified using the exponent rules. We should always check that the answer is in correct scientific notation, because multiplying and dividing can cause our numbers to change their place values. So for example, we have 3.5 times 10 to the power of 8 times 5 times 10 to the power of negative 3. So if we rearrange our factors, we can have our leading digits together and our exponents base 10 together. 3.5 times 5 is 17.5, and 10 to the power of 8 times 10 to the power of negative 3 is 10 to the power of 5. Remember, if we have the same base, we add the exponents, which is what we have here. Now, 17.5 is not the correct way to write our leading digits to have our number in scientific notation. So we can write 17.5 as 1.75 times 10 to the power of 1, because we've had to move our leading digits over one place value. And we can finally write our answer in correct scientific notation as 1.75 times 10 to the power of 6. 1.8 times 10 to the power of 11 divided by 6 times 10 to the power of 7. Now 1.8 divided by 6 is 0.3, and 10 to the power of 11 divided by 10 to the power of 7 is 10 to the power of 4. Again, this is not in correct scientific notation, but by rewriting 0.3 as 3 times 10 to the power of negative 1, we get our final answer of 3 times 10 to the power of 3. 5 times 10 to the power of negative 4 times 9 times 10 to the power of negative 9. Again, we can multiply our leading digits and our exponents separately. 9 times 5 is 45, and 10 to the power of negative 4 times 10 to the power of negative 9 is 10 to the power of negative 13. 45 can be written as 4.5 times 10 to the power of 1, which means our final answer is 4.5 times 10 to the power of negative 12. 5.6 times 10 to the power of 5 divided by 8 times 10 to the power of 18. 5.6 divided by 8 is 0.7, and 10 to the power of 5 divided by 10 to the power of 18 is 10 to the power of negative 13. 0.7 can be written as 7 times 10 to the power of negative 1, so our final answer is 7 times 10 to the power of negative 14. Let's look at a more practical example, using actual values that a scientist might have to deal with. The Earth is 1.496 times 10 to the power of 11 meters from the Sun. Light travels at 3.0 times 10 to the power of 8 meters each second. How many seconds does it take light from the Sun to reach the Earth? So we can write this as division. 1.496 times 10 to the power of 11 divided by 3.0 times 10 to the power of 8. Now we'll make things easier here by using a calculator, and we get 4.99 times 10 to the power of 2. Now the way you actually type this in a calculator will change depending on what type of calculator you have. So make sure you check with your teacher or the instructions that came with your calculator for how you should correctly enter scientific notation on your device. Now because our exponent here is only 2, it might be more practical to write this as an ordinary number. So this is 499 seconds, or 8 minutes and 19 seconds. This is a rather mind-blowing fact. It takes over 8 minutes for light to go from the Sun to the Earth. So that means when we look up in the sky and see the Sun, we're not actually seeing the Sun. We're seeing what the Sun looked like 8 minutes ago. That's the type of fact that we were only able to figure out because we were able to operate with such large numbers using scientific notation.